Welcome back to Airdrie Public Library Virtual Programming. So last time we made these curious little hexaflexagons, a three-sided piece of paper. This time we are going to make something even more curious, a one-sided piece of paper. So I have this little friend here. His name is Mobius. You can tell he's pretty cool because he wears sunglasses. But he's got something to tell us. He says, what if I told you there was only one side? Now we're back here at Mobius. This is of course called a Mobius loop. It's a little loop of paper with a twist in it so that the top side of one end meets the bottom side of the last. And that creates a piece of paper with pretty much one edge and one side to it. So let's create one. So I cut out a long and thin piece of paper here. I'm going to put a bit of glue on one end. You can use tape if you prefer. Now I'm going to glue this end to the other end, but put a twist in it. And let that set. So now we have a Mobius loop. And we can start drawing on it. To prove that this only has one edge, I'm going to go along the right side, putting some marker on it. So if we only go along the one side, in a normal piece of paper, we should come back around, and only the right side has marker on it. So what do you think is going to happen when we go all the way around this paper? What will it look like? Right side, right side. And we come back here. And on the other side, you can see that we only went around the right side, but we can see it on the back side of here on the left. So there are actually two edges to this. But this edge here is the same as this edge, so it's kind of like there is just one edge to it, because we have marker on both of these edges. If this paper were completely transparent, we'd be able to see through both of it, that there is clearly marker on this edge and on this edge. So now let's try a different experiment. I'm going to take my scissors, and I'm going to cut the middle, and just keep cutting along the center. Now what do you think is going to happen? We're going to end up with two different Mobius loops, or one really long one. Well, that's kind of interesting. We now have twice the amount of distance that the Mobius loop covers, but it's only half as wide as it was before. Kind of neat. Thanks for tuning in, and I'll see you next time.